Hello and welcome back. Today on the bench is what is it? It's one of these. It's a Type CA plug-in unit for a Tektronix 545B oscilloscope. So, as you can see, it's looking a bit forlorn. In fact, the whole of the plug-in is a bit worse for wear. We've got period cobwebs, a la horror film thingy going off. We've got rust, we've got, it's not a very good fettle, bless her. So the problem is, I've had to literally, as you can see, there are lots of nuts, bolts, washers. I don't know where all of those go. I've got a vague idea, but all of that to get at this switch here. As you can see, we've got a ball bearing. So when I first got this, probably because it's been stored in various sheds for years and years and years, all these controls were seized, every single damn one. And I don't mean just a little bit seized, I mean seized with a capital C. So basically what I had to do, I make my own sort of penetrating oil, which is a mixture of red diesel and a bit of oil, the oil that you stick in your motorbike car. So a lot of that was put on the little locking nuts, grub screws, got the knobs off and all that, and as I said, these were seized up good and proper. So a bit of my own made penetration oil on there, and then even that didn't work. So in the end, basically, can't find them. I had to use a pair of mole grips to get hold of the shaft there and try and turn it. Even that didn't work. So in the end, I basically had to use some heat, lots of it, judiciously applied to the area. And even now, I mean, they're okay, but they're not, 100%. So got those unseized, and then the problem was this one here wasn't indenting properly. So these are the controls that select our vertical voltage, what do you call it? I can never remember the frigging right word. Voltage setting, let's just call it a setting. So whereas this one on this side was okay, click, 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 this one wasn't. And what it was is this little spring that keeps that. You can see on this one, I've got like this sort of brass sort of spring, and when this is mounted with this base plate there on, that'll sort of push against that, and the springiness of the brass material will, put a bit of pressure on that. What do you call it? Ball bearing. And if you look in there, got this like sort of ribbed washer affair, and the ball bearing clicks into those. So anyway, managed to get this off, and as you can see, it's got some sort of metal fatigue. It's definitely metal fatigue. As you can see, if you look really closely, which you probably can't use in this bit of a gash camera, there's like, it almost looks like, do you know what pot metal is? Monkey metal? It's like a very sort of cheap nickel crappy metal that they used to make toy cars out of and things like that. And that has a similar sort of grainy sort of structure when snapped. And that's what that sort of looked like. So, now we get to the point. What the hell do you do? I mean, to try and replicate a switch like that, it's going to be a nightmare. However, I do have, as you know, several Tektronix 500 series scopes. One there, two there, another one in there, another one upstairs, another one in the shed. Most are not working. And so I've just pulled this off a non-working Tech 545B, and voila, we have a spring not made out of that crappy brass stuff. I did think about soldering this, but no, it's I think the metal would probably just go again. So I pulled this off an old Tech 545B. We'll take the spring off, fit it, and then I've got to try and remember where everything goes and put it back together. So yeah, that rather long convoluted story is why it's all in bits. And so the plan is put it back to bits, put it back together, get the old arrows on it, give it a good blowout, and then put it in the scope and see if it works. So yep, that's all pretty ready to go on. I put it on once and then noticed that I got a lot of these big washers and obviously couldn't remember where the hell they went, so I'm using forensic examination to find out where the bloody hell they went. This will make putting the buggers back just a little bit more challenging. This was especially challenging to get off because a lot of these nuts, I don't know if you can see, like here, I've got this lock nut stuff on, and the only way to really release a screw nut or whatever with that on is to heat the buggers up, which is either via a big iron or blowtorch. So yeah, I've had to get pretty medieval. As you can see, there's a hammer over there which I've had to use a few times. Here we all are again later. As you can see, got the first sort of structural plate on. No cursing or swearing was involved. It was reasonably straightforward. So, oh yes, the only thing I've got to do now is remember to put these on, because the screws that go on there go behind this plate. I had a hell of a job to get one of them off. One of them had, I've noticed this sometimes you get, I mean this feels like, well, let's see what it is. Yeah, it's aluminium. This is aluminium or a alloy of aluminium. Problem with aluminium is if you use like a steel screw on it, you can get where the thread of the aluminium basically sticks to the steel thread. I had a hell of a job to get that out. I had to heat it up, turn it a little bit, then it'd seize, heat it up again. I mean, I'm talking pretty heavy heat here onto the screw. I think, yeah, there, that's where I had to heat the bugger up. So it wasn't fun at all. That's the front panel on. Just putting the knobs on now and trying it. This one here is still not as good as that one, still not as clicky, but it might be because I put a bit of silicone grease to stop the ball bearing falling out. If you've ever worked on any test equipment of any description or anything that's got knobs with grub screws in, you will know that sometimes they become stuck and you either, well, you end up having to bust the knob off and brute force it off. To prevent that and to help people in the future, I put a bit of copper slip on there. So I've got the first two on there. I haven't shown you the clickiness, have I? That one's still not, I mean, it indents now. See, that's got a click. It hasn't, but that hasn't got a click, but at least it indents. And the cowls are set to the right doodah. I haven't cleaned the knobs in soapy water or anything like that. I don't really go to all that attention on a lot of my test gear, because it's really dusty in here. It's not a pristine American workshop, you know, where they've got a bloody great big massive room like full of what do you call it, what's that stuff? Air conditioning and all that malarkey. It's an old shed on the back of a Victorian house, so there really is no point going to, you know, the level of making everything lovely and shiny, and half the time my hands are covered in crap anyway, so it is what it is. Call it protective dust. There we go. An indication of how seized some of these switches, well, how all of these switches were, is just this invert normal polarity switch. So I've got a pair of mog grips on there on that shaft. That isn't moving at all. I actually did unseize these by putting some of me homemade penetrating oil and heating it up, taking a valve out and heating the bugger up, which I did, and it unseized it, but it seems to have re-seized, so I'm going to have to do that again. Right, we'll try to unseize it again. The reason I'm not removing the valves is because I know what valves go where. You know, that's a 6AU6, but it's I've learnt through trial and error, you can put a valve in one position, same valve, you know, the same sort of valve in the same position, and one, it'll knock it out of calibration, although that's not particularly my main concern here, or it won't work at all. Alright, that's unseized it, see? I hope you can see that. We like to apply, whoops, I like to apply quite a bit of, where do you call it, quite a bit of heat on that. Let's get a knob on that. I don't really want to scratch this fascia plate. Ah, see, that's seized again. Oh, bloody bells. Look at that. That's seized again, look. Wow, that has seized. I'm turning that knob and the bugger's seized. Right, what I'm going to try and do is melt some of this, where do you call it in there? Oh, what's it called? Copper slip. Try and melt a bit in there. I mean, these are like precision blinking electronic instruments. You shouldn't be like having to grease the buggers up, but we do. And that's melting the right, oh, there we go. I used to leave it on normal, innit? Because it's not really a switch you use much. Right, okay, that's a great idea. I've just melted the knobs on my flute bench meter like a pranet. Right, let's leave that on normal and bloody well be done with it. Right, I'll carry on because I'm making silly mistakes with this tripod being here. Here we are the next day. As you can see, we've got a display on the screen, but it's well dodgy. Astigmatism doesn't really help, so we've got some sort of noise issue, and the position thing is a bit wrong, so let's have a fiddle with a couple of these presets. DC balance does nothing. Gain adjust. Right, that's doing nothing. There's a few pots inside we could adjust, so well, that's on A, that's alternate. What have we got here? I'm just in the B position. Note. Oh, hold on, there we go. So we've got A. Oh, right, this is a bit odd. So we're just in A, and we've just got the one trace on alternate. Oh shite, it's gone. Hold on. And then that was adjusting it. B was adjusting it. Right, alternate. Let's try chop. Oh, where are we? Chop. God Jesus, these controls are like wrestling with a bleeding hippopotamus. So that's not working. Let's go back to alternate. Alright. Right. Alternate. That's not right, is it? Well, that's a B. And A also just a vertical. B only. Alright, getting nothing. Nothing. A. We've got an A. Which crop is it? Let's try sticking the signal in. One kilohertz, amplitude 2 volts. Just make sure we have got frequency 1 kilohertz, amplitude 2 volts. Let's just make sure that we have got a signal there. Oh, Lord have mercy. Why does everything just get... I mean, never mind. I shan't moan. Yes, we have got a 1 kilohertz signal. We know there is a 1 kilohertz signal. But when we put that there, we're getting nothing. Now I cleaned those things up yesterday. So nothing there. B. Ah, now we have got a B, but hold on, we're on AC, DC. Right, so this obviously needs work. So we've got something, but there's obviously some sort of crap. So we need to dig into that a lot more. Now, obviously, to try and work on that at the same time as adjusting it and checking traces with the other oscilloscope, we need some sort of extender card. I haven't got one. However, I've got this sort of extension lead which works sort of, but the other day when I tried it on, I think it was either the L type there or the 1A1 dual trace plug-in, it didn't work because I think of shielding. I think like basically inside here, try and, oh no, don't tell me you ain't gonna hook it up. Alright, okay. Well, that isn't coming out now for some reason. Have a look at that in a minute. Inside there is a shielded enclosure. So when you're trying to amplify signals like, what's that, 1 division 50 millivolts, so you could be, you know, you're talking very low signals, high gain circuits, you need a screened enclosure, I would think. Yeah, that's inside the 1A1. As you can see, this one is also in a bit rough condition. They're remarkable pieces of workmanship, they really are. And that's silver, that is, or silver plate. I love all the mechanisms some of the mechanisms are just amazing. Like for instance that one, you've got like a cog, I'm sure there's a name for it, with a big chunky thing there. You've got various linkages and clutches. See, because that like, it's got a cam, that cam comes round and then switches in other circuits. They really are remarkable devices, but you know, the only way you could clean one is to take it all apart. But to do so, you know, you're talking, it may never work again, not with the level of knowledge I've got. And obviously you've got to take hundreds of pictures. These cards actually pop out, little plug-in sort of things here, which is always a possible area of problems. This one uses, this 1A1, this particular series, uses new vistas, a couple of new vistas there, and a lot of transistors, as well as, has this got any? I don't think this has got any valves in it. Yeah, this is all transistor, this is. You can see they're all in sockets, so yeah, I've got a lot of work to do. I just usually just try and manage with what I've got with this type D and a type L. I've got about 3 type L's. Right, I'll continue on and we'll see if we can get it going, eh? We've found one fault. So this is the signal path. Your signal comes in through these connectors, either selected by this switch, DC or AC, and all AC does is puts a big, well, a high voltage capacitor in series with the, you know, signal sort of thing, blocking DC or letting and only blocking DC and only letting AC signals through, or you've got DC, which is a direct connection. That connection then leaves that into this wire here, which goes into your attenuator switch. That attenuator is switched by precision resistors, and we've got a few capacitors, resistors here, and then that signal goes into here. Try not to juggle you too much because I know how annoying it is. Goes into here, which then goes into here, which is either a standoff or it might have some capacitance as well. It looks like it's either a variable inductor, oh no, it's a capacitor. So that goes in there, and then that goes into our first gain stage, I would think, or I would think that's more likely to be a buffer. So they are a 6AK5, which as far as I know, where are they? EF90, right, that's a high frequency pentode. Okay, threw me a minute there, I thought it might be a diode, but that wouldn't make sense. So they go into those gauge stages, and as you can see, we've basically got the 2 channels are mirrored all the way across. Yeah, all the way across, and then I would think these, right, we have got a diode here, a 6AL5 and 3 ECC81s, which I would guess is your final sort of stage. They will probably be configured as cathode followers again as a buffer to push the signal through that connector there into the rest of the oscilloscope. So that is one reason why we haven't got a trace on B. Is that right? No, A. Well, we haven't got a signal on A. So we've got to solder that on. Then the other thing is to fiddle about with this this is the only adjustable pot inside. The other adjustable pots come out on the front there. So basically what we can do, use our extender, plug it in on the bench, put a signal in, follow it through the attenuator to this point here, and onto our first, I would say that would be a buffer, follow it to there, and make sure that we've got a signal coming out there. Now that the rain has stopped a little, I want to go and get the arrows out and give this a bit of a blow off. There we are, another morning. Bloody freezing in here. Yes, you can see the old breath. Somebody made a comment about why I wear granny jumpers. I got 2 jumpers on. The reason is because it's frigging cold and I got no heating in here, and I'm too poor to put the heating on. Anyway, more progress on this. Found a couple of wires off yesterday when we had all those switches bouncing about. Some of the connections became unconnected. Fixed those. Another issue I found was signal in here, signal just behind there, not present. I'd cleaned one of the sockets, the inside pin, not the other. That was the reason. Basically got, I don't know, well, we said this was made in 1965, do the maths, 60 years of gunk basically, stopping the signal getting through. Anyway, here we are again. Let's bung it on and see if it works. These do take it, this scope here takes a long bloody time to come on. Having a crafty fag. Some of you do like the fact that I smoke in these politically incorrect times, or is it politically correct times? There we go, click. Have we got anything? No. Where is it? There we go. Hoi hoi! We've got a trace. We are on. Do we have control? Do we bollocks? We've got control on B. So what's this telling me then? Okay. That's very... You see that doesn't look right. Oh, right, we're on, what we're on, right, let's make sure the man at the controls is, what they're calling it. Right, we've got plugged into the calibration, B, nothing, and we're on 1 volt, so we should have something. A, bugger all. Hang on. Somebody's been messing with the controls again, so we've got nothing on at A. Alright, oh, that's B. Let's try B. Aha, okay, ooh. Right, we're getting somewhere then. We're still not out of the woods, but right, so we've got B. Move the camera to the other end. Try and rest you. Let's have a look then. Okay, that's obviously not a square wave. Aha, no, it is a square wave. Righty ho. Okay, we've got some. I did clean the switches yesterday, believe it or not. That's our right. Okay. Strike a light. Right. You see, we've got some. Ignore them. Oh, okay. What the hell have we done now? We've just gone off. Right, okay, no. I must remember. Right, so the trace is obviously not 100%, is it? Try and get that to stay still. Oh, trying to focus. I know you can't use a tripod, so you just have to put up with it, sorry. Right, okay, well we've got something. This is the... we've got some sort of progress. Yes, we've got iffy controls, but as I said, it's been sitting for 60 odd years, or God knows how many years. So we're still not out of the woods yet, but we've got a trace. So at least we've got a trace on B. Have we got, I mean it's still not perfect, but right, have we got an alternative sweep? Where's our B? But also A controls B in the alternate setting. Right, where the hell are we? That's supposed to be chopped. Right, and now we've got, right, so we've got no chopped. Added algebraically. The two channels added algebraic. You know what I'm saying. Algebraically. What the fuck is it called? Where are we? Algebraic. Oh, you know what I mean. Okay, so we've got some sort of compensation issue. That's on an added thing. Right, that's supposed to be A only, but we've got a trace on B. Nothing on A. Sweet FA. So back to B. And that's supposed to be B. God knows. So we've got B. Alternate. See that? I've got. Right, so there's something not quite right in there. So, what's the plan of attack, Mr. Diabolical? Well, the first thing, what have we done so far? We have got the switches more or less functioning. We've cleaned the switches. There's nothing more we can do there. We haven't scooched it out with the air hose, but I mean a few cobwebs should not make much difference. Yeah, they might sort of conduct or something with all that dust on them, but you know. So the next thing really is to check the valves out. Although I don't think that will be the issue, but that's the thing to do. So so we've got B working, so check the valves out on both channels and find out where the A signal is getting to or not getting to. I chased it through, which is that one? This is A. So all this jigging about, this is channel A. I got it to here and I got it to here. So we're getting into there, and then from there it goes across into this valve here. So basically check the valves. So most of these are 12AU6, 6AU6. Just about all of them are. How many we got? 1, 2, 3, 4, 5, 6, 7, 8. So we'll check all of those out first, and then we'll check our 1287s out, and then we'll check these 6 AK5s. These, we're going to have to look those up, because these, with the label on, are tested to various parameters. Pardon me. The other thing I have done is pulled each valve in and out to sort of, you know, get the good contact on the pins more later. So we are testing the first 6AU6 connected as a triode, not using revolve tester. I just find it quicker just to use all my bench power supplies and then just, you know, knock it up on this board. So we should be testing at 12.2. We are running at 14.18, 14.2 let's call that. So that one's a good one. This one is testing okay, but less than the last one. You can see that 12.5, 12.4. And so the next lot, let's kill that HT, kill the heaters. So the next lot, they're the only two 6AU, oh no, there's these two here. So there's these two here that are supposed to be tested at whatever parameters. I'll just test them normally first, and then I'll have a look at the Tektronix data on that. I've got it somewhere on my computer. It's easily available online if you look on TechWiki 140. Okay, first interesting result. That's reading at 2.5, and that's one of those ones with the label on. Well, it is a 6AU6, yes it is. Okie dokie, so that's not good. We'll test the other one because that seems a bit odd. I've never had a valve test that bad before. So the other one tests badly, tests weak as well. I'm going to look into these ones that are labelled 020381. They look to me like your bog standard 6AU6, but they're obviously selected for certain parameters. This is just a mullard. This is a electric. I can't see, my eyes are really bad and the light's not good in here. Yeah, we'll look into this further. Well, finding the specification for this valve turned out to be a little bit more problematic than at first appeared. Mind you, there's another number on there which I probably missed because my eyesight's pretty bad. So this reads 020381, which I think is a part number, but there should be another number before that. Here is our Tektronix valve specifications. In a lot of the cases they're either aging them, or they're looking for specific microphonics, or in this case, like I couldn't find that one, so jump over to the CA manual, and these are our blah blah blah, and it says use specification 157059. Jump back to our thing, and here we are. So 6AU6 electron tube, sharp cut-off pentode, aged 72 hours. Oh, okay, see specification 02207, oh for fuck's sake. Microphonic output under specified conditions not more than 160 millivolts, cathode bias matched within 0.5 volt of each other. Okay, so according to the CA manual it's saying they've got to be balanced. After the microphonic check, this part is identified as blah blah blah. Test conditions for the microphonics, vibration conditions, vibration test, test conditions for a balance check. This is probably the main one that we're after. Plate voltage 225 volts, plus or minus 1%. Screen voltage 107 volts. Cathode current, or anode, no it is cathode current because cathode would be your anode current and G2 current altogether, 5 milliamps. Pin current. Right, the thing what it isn't giving us though, you see we've got all the test conditions, 225 volts, 107 volts, but we haven't got our control grid voltage. Cathode bias of two tubes of a pair shall not differ more than 50 millivolts. Cathode bias of all tubes shall not be less than blah blah blah. Shall not be less than 0.7 volts nor greater than 4 volts. Well, that's not really telling us much at all. 157 blah blah blah, serial number, label attached to tubes. Both tubes of a pair have the same serial number. Right, this is a different thing. Right, so we're none the bloody wiser. Either way, this is still, I don't think, I think it's knackered. So I'll go and get some good known 6AU6s, new ones that I've got upstairs, bung them in and take it from there. Having said all that, we've still got a hell of a lot of faults on this bloody thing that look to be problematic. Let me just have a look, find this schematic, and as you can see it's a bit busy. We've got a lot going off. So basically it comes in here from our attenuator into this first valve. So these first valves are obviously the one to check on channel A because we're getting no signal. So that's just, looks to me like that is configured as a bloody, yeah, it's configured as a cathode follower.